Hello, and welcome to the CPM webinar series. Today's topic is Understanding CPM's Unique Ring Extruder Technology. My name is Christian Davis, and I'll be your moderator for today's event. With locations around the world, CPM is a leading global supplier of twin screw extruders, extrusion systems, high-performance replacement parts, ring extruders, thermal equipment, and supporting services. Our webinars are intended to service, support, and inform you about the latest technologies, maintenance methods, and trends in the industry. Presenting today's webinar is Joerg-Mayer Lutz. Joerg has over 40 years of experience in various industries, including extrusion. At CPM, Joerg has worked on ring extruder projects for more than a decade, helping develop solutions for challenging continuous mixing and degassing processes. If you have any questions during the webinar, please type them in the questions field. If it's not answered, you'll receive a follow-up response by email. Joerg, I'll now turn it over to you.
Thank you, Christian. Hello, and thank you for participating. Today's topic is understanding CPM's unique ring extruder technology. First, I would like to show the agenda of this webinar. The ring extruder, a brief excursion into history, technology and design, process engineering, application examples, and finally, conclusion and questions. We have a history of almost 100 years if we talk about the development of polymer extrusion. 1930, the first single screw extruder were introduced into the market for polymer extrusion. 1957, the first twin screw extruder were introduced to the market. And finally, 1998, our ring extruder with co-rotating screws were introduced to the market. So that is an evolution from 1 to 2 to 12 screws over almost 100 years. We just present you some first ring extruder projects when we started with this new extrusion technology. For example, we introduced our ring extruder for PET recycling. A small RE5 with approximately 1,200 kg throughput were one of the first lines and in the recycling business. And we had another RE1 project with nano compounds and RE6, a compounding line for PP compounding. This were the first projects with the ring extruder. In total, CPM's extrusion solutions with twin and ring, we have manufactured approximately 5,500 lines globally. And so we have a benefit offering two different solutions and technologies, and we have as well the option to compare both systems in our lab. That is an advantage for customers to evaluate which is the best technology for their application. The ring extruder is a unique technology. We manufacture different sizes of this extruder. Small size is 90 millimeter lap size, so-called, up to 100 millimeter screw diameter for industrial applications. First of all, I would like to show you a short animation regarding the ring extruder. So you get a first impression of the machine. We have 12 co-rotating intermeshing screws arranged in a circle. It's a modular design with different sections, and so it can be individually designed following the requirements of the application. Generally, the ring extruder is used for continuous mixing process and has its strengths in degassing and devolatilization processes. If you compare it with the ring extruder with a twin screw extruder, it's a quite similar setup. We have a drive in the case of the RingExtruder, mostly a water-cooled AC drive. A safety clutch, that can be a mechanical safety clutch or pneumatic safety clutch. Then we have a special gearbox. It's a combination of a reduction and distribution or planetary gearbox. It's a special design by CPM. Then follows an inlet barrel and the complete process section. It's a modular design with barrels, screws, and a core. The core, that is different to the twin screw extruder, is the counterpart to the outliner. So it's a stable, fixed part in this process section, and it doesn't move. It's just the counterpart for the outliner. If we talk about the modular flexible process section, there a flexibility regarding the layout setup. So we have different barrels available. We have closed barrels, open barrels, combi barrels, 40, 60. So this is quite similar to a twin screw extruder. We have a wide range of different screw elements, and so we can feed at different positions solids, powder, granules, liquids. We have different materials available for the setup of the machine, starting with nitriding steel up to PM materials. So this is a very easy handling of the machine, and you can always adapt to the requirements of your process. There is a wide selection, a wide range of different screw elements, and here a small video showing the details of the screw elements. We have conveying elements with different pitches. We have mixing elements. We have special so-called high performance elements, kneading elements, and for sure the different belts for different parts of the process section. The high performance elements I mentioned are special designed screw elements. They were developed during the last decades for improving the extrusion process, especially for the ring extruder, but as well for twin screw extruders. So with these elements, we can, for example, achieve better homogenization, especially if we process high filling rates. We can avoid agglomeration with these kind of elements. We can reduce energy input and improve degassing processes. This slide shows you some pictures of a typical ring extruder screw package. What you can see, the ring with 12 screws, the shafts, different types of screw elements. We have the core. Here in this picture, you can see the core. The core is a design of a shaft with core elements, and these core elements are designed with cannulars, so they fix the screw, and it's a counterpart to the outliner. So this is totally different to a twin screw extruder. As mentioned, many different screw elements are available for the different applications. Another special feature, of the ring extruder is a single torque monitoring unit. This unit is very important because we have the possibility or the option to measure continuously the torque of each single screw. And this is important for safety reasons. So we can detect immediately, for example, a deviation from standard torque, and this could initiate an emergency stop if required. Or it can be used as well for quality management because each application has a typical generate typical values of the torque. And if, for example, if we see a deviation due to issues with the feeding system, then you generate a deviation regarding the torque, and this is immediately shown on our panel. And then maybe we can create waste discharge by using a valve. Another very typical feature for the RingExtruder is the special combi barrel with two openings. That means we have the possibility to feed not only from one side, but we have the possibility to feed as well at the same position from the other side. This is as well possible regarding degassing. This can take place from both sides. Very important, for example, if you want to initiate a kind of devolatilization process in the process section, then this is a very intense process. We can connect from both sides vent stuffers with a vacuum, and then we can decrease, for example, the content of monomers. Additionally, we have the possibility to combine, for example, a side feeder, a feeding process with a degassing process, because if you feed, for example, powder into the process section, that's normally happen that you then convey as well air into the process, and to avoid this that this air is mixed with the melt, we can discharge the air with a vent stuffer from the other side. So this is very helpful for the feeding process and generate a good mixture for the complete process. Furthermore, we have as well the possibility to feed liquids. Can be as well a combination. For example, just a few days ago, we had another lab trial, and we saw we could feed fibers from one side into the process, and from the other side, we could feed an oil into the process. And this was very helpful to create a very good homogenization. The advantage of the RingExtruder is not only that you have the option to feed or to split a feeding process in several steps, but as mentioned, with these special combi barrels, we can feed from both sides, or we can feed and degas at the same location. So this is the picture of a RE7 with one feeder and two degassing units or vent stuffers. And on the other side, there's another picture. It's the same machine. You can see as well degassing unit or vent stuffer at this position, and additional openings allows further feeding steps or degassing steps to intensify the required process. Another important feature of the RingExtruder technology is the automation and sensor technology. So, as mentioned, we measure continuously the single torque of each screw. So we have a possibility to show the torque of the machine. This is there are different views available. You can get a diagram with the torque of all 12 screws together. You can create a view with a diagram with only 1 or 2 or 3 screws, whatever you intend to see. Then we have the possibility to show the temperatures and the pressure of the barrels and the die plate, and further information can be shown on the panel. We have the possibility to measure as well gearbox, motor, and core temperature, and each barrel and further units are individually controlled. The next slide shows you an animation of the ring extruder, because the ring extruder is not unique regarding the process, but as well regarding maintenance. So what you can see here, different parts of the machine with the motor, the clutch, the gearbox, and here the lantern. This is the unit for single torque measurement. And then we just have to loosen 4 screws so we can separate the complete process section. We can pull at the slide, and then we turn the slide in an angle of approximately 45 degrees. And with the next step, we can disassemble the sealing plate, and in the front of the extruder, we will disassemble the die plate or tip plate, and then we can disassemble the complete screw package, including the core. So this is very easy handling and gives the operation team the advantage, for example, to exchange in a very short downtime one screw package by another screw package. This is very important because for example, if we talk about continuous processes like recycling, it's very important to operate 24/7 without any downtime. And so after 8,000 hours of operation, the operation team can disassemble the screw package, check the inner surface of the barrels. If everything is okay, the new screw package can be assembled, and so after a few hours, the recycling process can continue. Now let's switch to the topic of process engineering. The ring extruder technology is based on the twin screw extruder technology, and this is as well the approach. The designer of the ring extruder, Mr. Plach, he was as well involved in the design and the layout of twin screw extruders, and he just summarized the typical properties of co-rotating, tightly intermeshing twin screw extruders. And these are the points: mixing, dispersion, split feeding, splitting the melt flow. Surface renewal is a very important topic for process engineering. The energy input by friction, self-cleaning by intermeshing screws, and for sure the ability for scale up from lab size to industrial size. If we review all these conditions, we see advantages and disadvantages regarding scale-up conditions. So, for example, the average shear rate stays constant in geometrically similar machines, and even the self-cleaning effect remains. But yeah, this is an advantage regarding the calculation of throughput of the free cross-sectional area or the volume. But we see as well some disadvantages of a scale-up because the number of 3 melt pool remains as well constant. And in consequence, you see some disadvantages regarding the ratio of surface and volume, the degassing efficiency in consequence, and as well disadvantage is that the quality of mixing and dispersion decrease with the size of the twin screw extruder. And this was the idea for the ring extruder. Because Mr. Blach, the designer of the ring extruder, he thought the most important zone is the apex zone in a twin screw. And if we scale up the twin screw to a bigger size, we still operate only with one apex zone. And this should be an advantage to increase the number of screws and therefore as well the number of apex zones. And so that is the result and the reason why he created the ring extruder. And this was a process. Mr. Blach started with tests with 6 screws, 8 screws, and finally evaluating all the tests, he came to the conclusion that 12 screws, co-rotating screws, shows the best results in the process. The principle of the ring extruder is based on the principle of the material movement. So we create in the ring extruder process section 12 parallel melt pools, 8 in the external processing area, and 4 in the internal processing area. The external melt pools move clockwise, and the 4 melt pools in the internal processing area, and they move anti-clockwise. This is very helpful for the exchange of material. And this is as well something that is considered regarding the distributive and dispersive mixing process. We can create a very high surface renewal rate, a high rate of surface renewal. The self-cleaning process is very intense because each screw has 2 neighbor screws, so the self-cleaning process is very excellent. And there's a very short residence time before entering the next apex zones. That is important regarding the intensity of the process. And so we receive very good results regarding mixing. The self-cleaning efficiency of the ring extruder is really surprisingly good. So I have just copied a short part of a video that I would like to show you now. This is a ring extruder, and we had a trial with rubber, simple rubber, and then we add only a small amount of carbon black, and immediately color is changing. But what you can see here is now that after a very short period, less than 1 minute, we receive again white, pure rubber. And this shows in a very good way that the self-cleaning process of the machine is excellent. This is really, I think, not comparable with any other extrusion system. Okay. So now let's talk about the mixing process. Distributive mixing is a option with I better say we have several options regarding distributive mixing. Sorry. We have the possibility to intensify distributive mixing by using same type of screw element, but for example by selecting a special mixing element or by increasing the gap between the screws, for example, with elements with reduced diameter. Another option is to combine conveying and mixing elements, shown here. So this is a specialty of the RingExtruder. You can combine different types of screw elements. And this is very helpful to intensify especially the distributive mixing process. And as a third option, you can combine conveying, reverse, and mixing elements at the same position in the extruder. And so you have a very high flexibility regarding the exchange of material, regarding the residence time at a certain position, and the intensity of the process and the energy input. Another very important feature of the RingExtruder is that we are able to intensify the dispersive mixing process. The dispersive mixing process depends always on the shear flow and the elongational flow. The shear flow, this is take place in the area between the flight tip of the screws and the surface of the barrel, the inner surface. The elongational flow is created in the apex zone, here between the intermeshing screw elements. And this is an important difference between these two processes because the elongational flow causes less stress for the material. It's very important for the intensity of the droplet breakage, and this is has a big impact as well on the energy input, the specific energy input into the process. So the droplet breakage means you intend to minimize the size of the particles by breaking up bigger drops into smaller. And this is depends on different values, parameters. The viscosity of the material is very important. It's very important the forces, the external forces and the inner forces that interact with the material, and this results in the efficiency of the droplet breakage. And if you compare a twin screw extruder with a ring extruder, you can see that the window or the process window for droplet breakup is completely different between these two systems. The twin screw extruder operates more with shear flow, and there you only have a very small window for droplet breakup. Whereas the ring extruder has the option, due to 12 screws, 12 apex zones, to focus more on the elongational flow. And the elongational flow opens a big window where you can create the droplet breakup. And this is a very interesting aspect because this allows you not only to intensify this process, but this gives you as well a big freedom regarding the layout of the screw configuration. We have compared the degree of elongation by doing a test. We compared a twin screw, almost approximately 60 millimeter screw diameter, and a ring extruder with 30 millimeter screw diameter, both with the same DODI ratio of 1.55. And this was compared with, because these two types or sizes of extruders can achieve approximately the same throughput rate. This is very important to have same frame conditions. And we choose the same screw speed of 600 RPM. And then we could detect a different regarding the irrigational flow of approximately 40%. So the ring extruder could achieve more than 40% higher rate of elongational flow in the process. And this can be explained by the setup or the design of the ring extruder. The distance that the melt pool needs to take before it next passes an epoxy zone is significantly shorter. For example, in the twin screw extruder, the path to be covered forms almost a complete circle, shown here with this drawing. Whereas in the ring extruder, there's an angle of approximately 140 degrees that must be covered before re-entering an apex zone, shown here with this drawing. So it's a very short time in the extruder for the melt pool before re-entering the next intermeshing zone, the next apex zone. And that's why the ring extruder allows to intensify the dispersive mixing process in comparison to a twin screw. It's the same position. And this has as well an impact on the specific energy input. So compared both systems, we achieve with the ring extruder approximately 30% less specific energy input in comparison to a twin screw extruder. This for sure depends on the material, on the process, on the application, and we saw different benefits with different applications, but generally the ring extruder definitely requires less energy input into the process to achieve very good process results. And this has a consequence regarding the profitability, regarding the process itself, regarding product degradation. So for example, if you compare design of a screw configuration of a twin screw extruder with the screw configuration of a ring extruder, you can see that the ring extruder screw configuration is less aggressive. For example, you can reduce the amount of melting zones or mixing zones, and so it's less risk to degrade the material. Then another point that is very important for the process in the ring extruder is the temperature regulation by cooling or heating, whatever is required. Here the drawing shows you that we have a very big or large surface regarding concerning the outliner, and we have the core. As mentioned, the core is the counterpart of the outliner. The core is not a part that moves, it's stable. And we use this core for cooling, for heating. This we can cool the complete core, or we can heat, for example, the first section of the core, or we can just cool the second part of the core. This follows the requirement of the process, and we can create a very good heat transfer due to the big surface of the design. And in combination with the number of melt pools, this is very helpful to create a very good heat transfer. So sensitive materials, for example, in the rubber industry, you have material that needs to be treated very sensitive, and for example, if you add additives, and these additives does not allow a process above 160 degrees, then you can create a first section where you heat up to a higher temperature to start the melting process, and then for example, in the second part of the process section, you cool down immediately the complete process section, and so you avoid any kind of chemical reaction or degradation of the material while feeding additional additives or oil or other liquids or powder. And this is very helpful to combine in one step different requirements of a process. We can use for the temperature regulation just normal water, chilled water, thermal oil, or other fluids. And for example, sometimes if you have to heat up above 350 degrees, then we don't cool the barrels, but we heat the barrels with thermal oil. And for other applications where cooling is important, but you want to avoid a kind of freezing process, then we cool, for example, the core with 80 degrees. So our thermal oil is heated up to 80 degrees, and the material in the process section has a temperature of 130 degrees, so you have a gap of 50 degrees and still good enough to cool down, but you can avoid any kind of freezing of the material, and this gives you a big flexibility regarding the temperature control in the process. And this is shown as well with these two diagrams, quite similar. We have compared ring extruder, that's the blue line, and twin screw extruder, different sizes of the extruders with different throughput rates, and we have compared the cooling efficiency. And the cooling efficiency of, for example, small lab machines is quite similar if you compare a ring extruder and a twin screw extruder, because the ratio of volume and surface and the design of the extruder allows a very good cooling efficiency. But in the moment you increase the size of the extruder, you see immediately a difference between the ring extruder and a twin screw extruder. And the ring extruder create a better cooling process, and so it's much more efficient to cool the melt pools in a ring extruder in comparison to a twin screw extruder. So this is the diagram regarding the cooling efficiency. And we have the same situation regarding the degassing efficiency, because cooling requires big surfaces, and degassing requires the renewal of surfaces, and if you have the option to create many new surfaces, then you can improve the degassing efficiency. And this is the same situation if you talk about lap sizes of extruders. The difference between the two systems is not so big. But immediately, if you talk about higher throughput rates, then you create a very good degassing process and efficiency with a ring extruder in comparison to twin screw extruder. And this is an advantage by we have many ring extruder designed for applications for devolatilization or for decontamination in recycling processes, because there we create a very good advantage or benefit for the process. The ring extruder is manufactured in different sizes. As mentioned, the RF1 is the smallest ring extruder. The RE1, as well as the other sizes, shows a high flexibility regarding throughput rate. So the RE1, for example, can be used for polymerization processes with small quantities but very long residence time. Then we talk about, for example, a throughput rate of 4 or 8 kg per hour with a residence time of 10 or 15 minutes if required, with a long LD length. But you can use the rings to the RE1 as well as a small production machine. And so you can achieve for some applications throughput rates up to 150, 200 kg per hour. So for sure it depends on the application, on the viscosity of the material, but this shows already the flexibility of the machine. Currently, the biggest machine in the market is the RE7. We use this machine, for example, for PT recycling with throughput rates between 4 to 6 tons per hour, or in the rubber industry for throughput rates up to 2 tons per hour. The RE10 is our newest project, designed now with screw diameters of 100 millimeters and designed for throughput rates, for example, in the rubber industry, very important market for us, up to 4 tons per hour, or for example, for the recycling industry, up to 12 tons per hour. This is interesting, for example, if you talk about reactor processes, then these reactor processes, polymerization factories, they have a throughput of 240 tons per day. And then in combination with the ring extruder as a bypass solution for recycled materials, you can plant the virgin material with this recycled material, and then you receive very good results with a content of 30%, 20%, 40% of, or even more of recycled material in virgin quality. Here, this is a picture, a comparison of the dimensions of RE7 and the RE10. The slide shows already the differences regarding the dimensions. A normal RE7, for example, has a complete length of approximately 8 meters. So if you talk about then for RE10, we have a dimension of regarding the length between 10 and 12 meters. But it shows as well, once again, the special design of the ring extruder, and in comparison to other extruders, especially twin screw extruders, this very short process section. Typical applications of the RingExtruder are applications you can find as well in the twin screw extrusion business. We have lines doing compounding. We have designed lines for master batches, for the reinforcement of technical polymers. Very strong as well in reactive extrusion, where you can combine many steps in one process step in RingExtruder. Bio-based polymers is a very interesting topic because we have the ability to degas, because if you feed, for example, fiber into the process, then we introduce high moisture content, then it's very important to degas, discharge moisture from a very sensitive material compound, and this can be done in a very good way with the RingExtruder. The RingExtruder is used as well in the food extrusion industry, and for sure, as mentioned, rubber compounding is very important for us. So here now some samples. Rubber compounding means applications in the tire industry. High performance tires are manufactured with compounds from the RingExtruder, floor coverings, industrial sheets, rubber-based adhesives, and many other applications are done with the RingExtruder. And we can feed many different ingredients into the process, and then you create a sheet like or a strip, like you can see here, as shown with the RingExtruder. And here, for example, the combination with different degassing or vent stuffer units and several side feeding units, and you create a very homogeneous strip of rubber. I would like to mention as well that we not only offer equipment, but for sure complete systems, plans. So here drawing, a preliminary drawing of a rubber plant, and you can see we can combine many different feeders, dosing units, grinding units in combination with silos, degassing units at different positions. So it's very complex systems, very challenging, because it's a continuous process, and in the rubber industry, the industry is normally used to batch processes where you just combine different quantities of materials, different materials in a mixer, and then you create a batch, and then you create another batch, and then you see deviations in the quality. And here, with a continuous process, we can achieve a very high grade of quality and a very continuous process. As I mentioned, recycling is another very interesting business for us with the RingExtruder. So we were one of the companies that started quite early with recycling. So in 1998, first RingExtruder was installed for PET recycling. And in the meantime, we have installed worldwide approximately a capacity of 500,000 tons yearly. So this is mainly a bottle-to-bottle process, mechanical recycling process with degassing, and then with a screen changer, and then a combination with a underwater pelletizing or underwater strand pelletizing system, and then combined with a SSP. But we, as mentioned, combine as well the rings to the in a kind of depolymerization process, and then with a combination with a blending process in a reactor where the material, the recycled material, is mixed with virgin material on a very high level of material quality. And flakes to film is another solution. Furthermore, we have, as a sample, created lines and designed lines for highly filled compounds, because due to the advantage of split feeding at several points and degassing, we can achieve very highly filled compounds. And this is very interesting in this market. And for sure, bio-based and biodegradable polymers is another very important market for us, and it's getting more and more interesting because as you see the idea of many companies now to transfer existing recipes on a bio-based base now, this is challenging, and here the RingExtruder offers solutions with a very stable process technology. Our innovation center in Laufen offers the possibility to execute trials. We have two RingExtruder with different lengths available. So the RE3 with 37 or 55 LOD, another RE1 with 34, 48 or 100 LOD. Very interesting, for example, as well for reactive extrusion. And then we have our twin screw extruder CXE45 with 48 LVD. That gives customers as well the option to compare as well processes, because we know approximately 90% of the processes can be done with a twin screw extruder. And the ring extruder is a niche product, and we use the ring extruder when twin screw achieves certain limitations. For example, regarding devolatilization, or if we talk about temperature issues, sensitive materials, degassing, demoisturing, and so on, then this is a task for the ring extruder. But it's always a comparison. You have to evaluate the advantages of the ring extruder in comparison to a twin. We have to compare as well the cost efficiency. And so if you consider all these points and evaluate, then we can recommend the best technology for a customized solution. And this can be checked in our lab. We have a lot of equipment around these extruders, so we have many different dosing units available. I think more than 30 different dosing units. We have vacuum system for low value operation down to 5 millibars approximately. We have a second flexible vacuum system available if you want to combine. It's one process step, different vacuum values. We have gear pump, we have screen changers available on the water and the strand pelletizer, a hot cut system, and grinding units, a grinding unit, for example, for rubber grinding or polymer grinding. We do approval tests for petitions. We support, for example, for any kind of challenge test for EFSA approvals or FDA approvals. So this is as well part of our business that we offer this kind of service. So almost at the end of my presentation of this webinar, a short summary of the ring extruder in brief. The ring extruder offers a continuous extrusion process with constant quality. we don't see any more batch-to-batch deviations. We have the option to offer high throughput solutions, for example, in the PET recycling business up to 12 tons, or in the rubber business up to 4 tons. Regarding polymer compounds, it really depends on the application. If you talk about polypropylene, polyamide, whatever is required, the filling rate, all these parameters, the recipes have an impact on the throughput rate. This can be calculated by our process engineering team. We achieve a very high efficiency regarding distributive and dispersive mixing. We can achieve a very low energy input, low energy consumption, and we can operate with very low processing temperatures. The cooling efficiency is very good with the RingExtruder and can be designed in really following the requirements of the process. This answers already the next point, process flexibility. That is another very important point. We can adapt the RingExtruder, the modular system of the process section, to the requirements of the application. Split feeding at multiple positions, highly efficient degassing at multiple positions, devolatilization, decontamination. This is a very efficient, excellent process with the RingExtruder. And regarding recycling, we can highlight that the RingExtruder has only a very low IV drop, for example, regarding PET recycling, and the color shift can be kept on a very minimal level. And finally, as shown in the animation, regarding, for example, the maintenance and regarding operation, only low manpower is required, and this is as well a very interesting aspect of the RingExtruder. Now, that's the end of my presentation, and it's time for questions from your side. For sure, we will answer questions as well with emails later on, if you can't answer the questions now, or if you will come back to us with further questions later on.
Thank you so much, Joerg. Thank you so much, Joerg. We appreciate it, and thank you to everyone who joined us. Just a quick note before, while we wait and see if we get any questions. Our next webinar will be June 25th, and the title will be Machine-to-Machine Transfer of Applications. A recording of this webinar will be available on 1cpm.com within the next week or two, where you can also find all of our previous editions as well. So this concludes today's webinar. If you do have any questions or would like to reach out to Joerg directly, please feel free to email us at extrusion.sales@cpm.net, and you'll receive a follow-up by email. Thank you.
Thank you.